Hey, where do bees go to the bathroom? At the BP station, of course. That's a funny one. If you don't know, BP is like a oil and gas company. They also have, or and there's also a BP gas station. So, anyways, inequalities with multiplication and division, and this is the last video for our whole lesson on inequalities. So, awesome. We're coming to the end here. A long I can statement. Take the time to get it down though. I can solve inequalities with multiplication and division. That's the new thing, okay? Using the same method of solving equations and flipping the sign when necessary. This flipping the sign when necessary is really the only new thing that you kind of have to learn. All right, solving inequalities with multiplication and division is the exact same process as solving equations, but, or except, there is one special rule, okay? And if you can learn this special rule, this is going to be easy for you. Check it out. All right, the one special rule. Write this rule down. If you multiply or divide by a negative number, you have to flip the inequality sign. And this is very, very, very important. Let me show you what I mean. I'm going to write down a true inequality. 2 is less than 5. You know what? Let me use a different number here. 2 is less than 6. That's a true inequality, okay? Now, I am going to divide both 2 and 6 by negative 2. Now, remember when we had an equation, we could divide or multiply both sides of it by the same thing and it didn't change the equation. That's not quite true with inequalities because, see, if I was to divide both sides by negative 2 on this inequality, look what happens. 2 divided by negative 2 is negative 1, and 6 divided by negative 2 is negative 3. It resulted in a false inequality. I started with a true inequality, 2 is less than 6, and I ended up with a false statement. Okay, so from true to false, because negative 1 is not less than negative 3. Negative 3 is not greater than negative 1. If you look at a number line, you've got 0 here, then negative 1, then negative 2, then negative 3. Negative 3 is smaller than negative 1. It's just way smaller. So we started with something that was true and ended up with a false statement. So if you ever divide by a negative number, the one special rule is you've got to flip the sign the opposite direction to keep the inequality true. And we're going to see that in some examples. Not all of our examples are going to have that. Okay, this first example, though, is not going to be one that we have to use a special rule on, because look, when we solve for x, or when we're isolating x, we have to divide both sides by 5, right? To do the opposite, this is 5 times x, the opposite's divide by. So these 5's cancel out to 1, so we're left with x is greater than 13. And if you're wondering how I got 13, 65 divided by 5 is 13. So what happened here is I didn't have to flip the sign because I didn't divide by a negative or times by a negative. So I'm good to go. So now I can graph it, and so I'm going to kind of be lazy on my graphing, even though I don't want you to be lazy. I'm just going to do a few points on here. And I have to use an open circle because it's greater than 13. So if I'm going to be greater than 13, open circle on 13. And then I can just kind of draw my line here. And that's my solution. X is greater than 13. Here's an example where we would need to flip the sign, okay? This is where the special rule comes in. When we divide or multiply by a negative number, flip it. So in this case, we have to divide by negative 4 to get rid of the negative 4. And these cancel out to 1, so that just leaves us with t. But I'm going to flip the sign the other direction. T is now greater than or equal to negative 6, because 24 divided by negative 4 is negative 6, of course. And that looks like a positive sign. So I'm going to change the way I draw my t's. That's bugging me. I like to draw my t's kind of long and curvy. So t is greater than or equal to negative 6. Way to flip the sign. Now we graph that solution. If you forget to flip it, you're going to get it wrong, so be careful. All right, I'm going to make this negative 7, this negative 6, and this negative 5. I need a closed circle on the negative 6 because it could be equal to. And I'm going to say it's greater than or equal to. So my line is going to go this way for infinity. All right, let's do one more, okay? In this particular problem, we have to solve the inequality and graph the solution, but it's a little bit different. This is m divided by negative 2. And the opposite of divide by negative 2 is multiply by negative 2. So I'm going to multiply both sides by negative 2. All right, when I multiply by negative 2, these cancel out to 1, so I'm left with just m. but I'm going to flip the sign because I multiplied by a negative number, and I get positive 16. So now m is less than or equal to 16. I'm going to scale my line. I want you guys to do more than just like 3 or 4. I'm just not making you sit through watching me scale this thing. Okay, I'm going to do a closed circle on the 16 because it could be equal to 16. Now m is less than 16, so I got to go this direction. Got to go that direction. And then I want to use arrows again to show that it goes on for infinity. Oh, it switched to right again. Did that one time in another video too. Okay, that's all there is to that problem. And let's talk really quick about this. I think this is the last example. Again, we would multiply, just with decimals, we would multiply both sides by negative 3.5 because we want these 3.5s to cancel. So we're left with y is greater than or equal to, what would that be? 3.5 times 7, 35, 21 plus 3, 24.5. 24.5. It's positive because we had 2 negatives. So notice I flipped the inequality sign, right? Because I multiplied by a negative number. And so we will graph that. And a quick reminder on how to graph the decimals. One way you could do it is you could just keep whole numbers here, but space them out a little bit more. And kind of, put that point where it will go on the number line. So it's 24.5. And then your solution is greater than or equal to. So your line will go out this way. Okay? And your number clue. For multiplication division, your number clue is, let me make sure I got the right one here. It's 1 less than a prime. It's 1 less than a prime number. Good luck, guys. I know you're going to do great on this.